Hello friends, myself R.D. Mahajan presenting my video on solution of partial differential equation by separation of variable method. Let us solve the problem. Differential equation is dou u by dou x is equals to 4 multiplied by dou u by dou y, and condition is u of 0 comma y is equals to 3 into e raised to minus 2y. Here u is a dependent variable and it is differentiated with respect to x and y, and the condition is when x is 0 for all values of y, we get the value of u as 3 into e raised to minus 2y, and therefore here the given differential equation is dou u by dou x is equals to 4 times dou u by dou y as equation number 1, given differential equation, given partial differential equation. As u is differentiated with respect to x and with respect to y, we consider let the solution be u is equals to capital X into capital Y, where that capital X is a function of small x and capital Y is a function of small y. We call this equation 2. Then differentiating this with respect to x, keeping y constant, we get dou u by dou x is equals to here y is constant term outside, differentiation of x is x dash. Then differentiating 2 with respect to y, differentiating 2 with respect to y, keeping x constant, this time we get dou u by dou y is equals to x constant and derivative of y is y dash. Substituting this 2 in equation 1, equation 1 becomes dou u by dou x is y x dash, all are capital letters, y capital x dash capital is equals to 4 into dou u by dou y, it is xy dash. Then separating the variables means we have to collect the terms of x dash and x on one side and y dash and y on the other side. Therefore separating the variables, we get, I will transfer this x to left hand side and y to right hand side, we get x dash by x is equals to 4y dash by we get x dash by x is equals to 4y dash by y, and we consider this ratio is equals to constant kc. Then equating first with last, we get x dash by x is equals to k and 4y dash by y is equals to k. Then integrating this term to get the value of x and integrating this with respect to y to get the value of y. We have x dash by x is equals to k and 4y dash by y is equals to k. Next step is integrating this with respect to x, small x, k integration of dx. F dash upon f, its integration is log of f, therefore here it is log of capital X is equals to k into x plus constant of integration c1. Then transferring this log to other side, we get x is equal to e raised to kx plus c1, that is equals to split this as e raised to c1 into e raised to kx, we get e raised to c1 is some new constant, we can call it as capital A suppose, into e raised to kx is the value of capital X. Integrating this by transferring this to other side, we get y dash by y is equals to k by 4. Then integrating this with respect to y, its integration is log of y is equals to k by 4 into y plus constant of integration c2. Again transferring this to other side, we get capital Y is equals to e raised to k by 4y plus c2. Split this as e raised to c2 multiplied by e raised to k by 4y, and therefore we get y is equals to e raised to c2 is some new constant b and into e raised to k by 4 y. Whatever these two values of capital S and capital Y, we substitute in equation 2. Equation 2 becomes here u is equals to, therefore capital X is a e raised to kx multiplied by y, it is b into e raised to k by 4y. That capital A into capital B is some new constant, therefore we can call that as c, suppose capital C, e raised to kx plus k by 4 times y, and we call this as equation 3. Therefore, this is the required solution with arbitrary constant c and k. Therefore, to determine that values of that constant, we consider the required condition. Here that u is a function of x and y, therefore I can rewrite that equation 3 as u is function of two independent variable x and y, and that is equals to c e raised to kx plus k by 4 times y, and then using the condition u of 0y is equals to 3 into e raised to minus 2y. It means we put x is equals to 0, value of u is 3 into e raised to minus 2y. Therefore, that u of 0 comma y is equals to, substitute x is equals to 0 here, we get c e raised to, when x is 0 this term becomes 0, we get e raised to 0 plus k by 4 times y. Therefore, and the value of that term is 3 into e raised to minus 2y is equal to c and e raised to k by 4 into y. Comparing these two sides, as sign of equality is there, constant c is the coefficient of that term of e raised to, it implies we get c as 3, coefficient of this term, and coefficient of y is k by 4, and here the coefficient of y is minus 2, we get k is equals to minus 8. Substituting these two values in equation 3, that equation 3 becomes u is equals to C, the value of C is 3. E raised to kx, the value of k is minus 8 into x plus k by 4. It is minus 8 by 4 into y. And therefore, we get that solution as 3 e raised to minus 8x minus 8 by 4. We get minus 2y as the required solution or required answer. And the method uses a separation of variable technique. Therefore, we get the required solution as 3 e raised to minus 8x minus 2y. One more I will discuss in my next video. If you like my video, please share it as well as subscribe to my channel to receive the notification for my new videos. For that, you have to press the bell icon. Thank you for watching.